In everyday life, we believe the world has a definite form, whether or not anyone looks. A table remains a table, even when no one is in the room. This understanding works very well at the human scale. But when we go down to the microscopic level, that intuition begins to fail. In quantum mechanics, particles do not have definite states before being measured. They are described by probabilities rather than fixed positions or properties. Before observation, a particle can exist in multiple states at once. Measurement seems to force the system to choose a single outcome. This phenomenon is often called the collapse of the wave function. It sounds as if reality only becomes definite when observed. This once led many to think that human consciousness collapses reality. However, that interpretation does not reflect modern science accurately. In physics, observation does not mean a human is watching. Any interaction strong enough to exchange information can act as a measurement. A particle colliding with its environment also alters its quantum state. This process is known as decoherence. Decoherence makes quantum possibilities indistinguishable at large scales. That is why our familiar world appears stable and continuous. Reality does not collapse because it is seen. It changes because physical systems interact with one another. Observation is just a special case of interaction. Humans do not create reality, but are part of its process. Reality existed before us and will continue after we are gone. But how it appears at each level depends on interactions at that level. Follow su.discover to keep exploring the subtle relationship between observation, interaction, and reality.